Notes from the review.
Live now.
Great. One.
I can't believe it. Like, he knows he's outnumbered, so that's why he's asleep, like, the whole time. Yeah.
Well,
okay.
that's convenient.
Listen.
Okay.
Meeting quiz. So hopefully they're like, you said last time they were the same exact questions.
Mm-hmm. Yeah.
I mean,
So I think we can read through them just to make sure they're the same. I think they're going to be exactly the same. I made a list. I wrote down all the answers from the review. So I think we can zip through it fairly quickly.
Okay, so, right.
The only thing would be like if there were a couple of them that I'm like guessing on. So we could just do that, but.
It is 32 questions.
Oh, 32? Well, there were only 26 on the review. There's the first one. Well, let's give it a try. So are we ready? Can we do question 2?
Yeah. I actively participated. So you can't even answer this one until you're done. So
we are actively participating. So question 2, given a 90% confidence interval of 45 and 105 for mean heart rate, which of the following is the best interpretation of this confidence interval? And I've got A, or the first one, 90% of all people. Whoa. Okay, it is not the same as the review.
So we are 90% confident that the true mean rate is
between 45 and 105. All right. So it is different than the review.
Yes, so there is no chance. Anything with a chance is death.
Okay. Yes. But it's similar. If you read it through, it's very similar.
They have the same ones. They just mixed up the answers, so we can't just go straight across. So the next 2 questions, researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go, no-go stimulus of males differed from that of females. Researchers randomly selected 20 females and 15 males to participate. The stimulus required the student to respond to a particular stimulus and not to respond to other stimuli. The researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they create QQ plots and see that they're normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? Yes.
So it would be yes. The distribution mean is each sample since that the data have been determined to be normal.
Right.
Yep.
Yeah, that's what I've got. And of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? And I've got independent samples.
Me too. Yeah, there you go.
Yeah.
So the third one.
How come they're independent again? Sorry, I got that wrong.
Because they're testing males and females, so we know that there's 2 groups, but whoever the male was did not determine who the female was.
Oh, duh. Okay.
So they're different in that way.
Okay.
Even though the people here nowadays think that that's female and male are not different anymore, but
yeah.
Besides that.
Yeah.
Okay.
So it's it says the researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of the bank customers is found to be between 3,402 and 4,142. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval? It says to obtain this.
Obtain the balance of 90 bank customers rather than 30.
Right.
And so why isn't it to change it to a 99% confidence interval?
Because 99 actually makes the spread wider.
Really?
Because then you're 99% sure that it's between these two numbers. But a 95, you can say I'm 95% sure it's between these two numbers, and then a 90% is I'm 90% sure it's between these two numbers.
Right, because then the n goes in the denominator. So if you make it a bigger denominator, it means a smaller number that we have to multiply to the mean.
Right, for the number of samples, yeah.
Okay.
The factory. Sí. Estoy en una reunión de la escuela. Ahora sí. Sorry, guys. I just opened the door to somebody.
Okay.
Okay. So the next question. Are we still in the question 5 or we are going to question 6?
We're at 6.
Okay. So do you want me to read it?
Sure.
The factory makes propeller drive shaft for ships. A quality assurance engineer at the factory needs to estimate a true mean length of the shaft. She randomly selects for 4 drive shafts made at the factory, measures their length, and finds the same sample mean to be 1,000 millimeters, right? Lengths are known as following the normal distribution, whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shaft. Input your answers on the margin error and lower bound and upper bound. So that will be one of the Excel sheets.
Actually, for this one, because they're not giving us any data, except for what's here in the paragraph. So it's going back to determining the confidence interval of x bar plus or minus z times sigma over the square root of n.
Oh, yeah.
But they don't give us sigma.
So
wait, they do.
They gave us the standard deviation is 2.
And then the n is 4?
Yes.
So if I do...
And the confidence interval is 95%.
So 1.65?
1.96.
Oh, nice.
645 was for the 90. That was good that you remember that. I had to go back and research this. I was like, I can't remember this to save my life. And I remembered once I saw it, it's like, oh, that's right. We have those.
So 1.96 times 2 divided by the square root of 4, which is 2. What? So it's just going to be 1.96.
Mm-hmm.
So 1,000 minus 1.96.
Minus 998.04.
Wait, does that mean I put it in a comma or like parentheses?
They added a question here. So, okay, no. So question 6 is determine the margin of error. So that's a different formula. But question 7 says input the lower bound, and question 8 says input the upper bound. So
I read that wrong.
Since we already did this calculation, let's go to question 7 and input the lower bound of 998.04, right?
Yes.
Is that what? Okay. And then question 8 is the upper bound of 1001.96?
That would be 1001.96.
Right. Okay. So now we can go back to question 6 and do margin of error. See, this one was not on the.
So the margin of error is just 1.96. No?
It will be 1001.96 minus 998.4 and divided by 2.
Oh,
is that right?
Right. That's what I got wrong in that one homework assignment.
Yeah, remember, we don't supposed to watch the videos anymore.
And they have the formula that you could plug it in, but that's essential.
Well, that was the video from from the teacher, not from the lesson actually. That explained that.
Wait.
So I got 1.96.
$1,001.
Yeah, because the formula is m equals z times sigma over the square root of n. Sigma.
Yeah, that's what I thought.
The square root of n is 2, so that comes out to 1, and z is 1.96, so it is 1.96. So you can get it both ways.
Yeah, so on that one homework, I tried to do it the other way, and it wouldn't give me the right answer, and so I failed it. So when in doubt, just do it the top minus bottom divide by 2, and then you'll always get it right.
Right.
So it's 502.94? No, that's not it. Sorry.
Right.
I don't know why I got that. Why I got that.
1.96, right? For number 7 is question 6 is 1.96, right?
Yeah, 1.96. I don't know why I did. Yeah, there you go.
Okay, it says question 9, to assess the accuracy of a laboratory scale, the standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weigh-ins is computed. Suppose the scale readings are normally distributed with unknown mean mu and standard deviation sigma equals 1.01 gram. Sorry, 0.01 gram. How large should n be so that a 95% confidence interval? That's a good question. Wow. That'll test if you know what you know. So we know that the standard deviation, so now we're going to solve for n using that margin of error formula that doesn't always work. But
right. Which simply put is n equals, and then everything in parentheses, z times sigma over m squared.
Okay, so everything squared, right, at the end?
Yes.
So 1.96 times 0.01 divided by 0.001.
0001.
Dang it. And then all of that squared, I get 38,416.
That's what I've got.
Yeah.
That's a lot of trials to get this scale to be 95%.
Well, to get that margin of error of almost nothing. That's why they don't have that.
Yep. That's so weird.
All right.
Question 10. The mean area of mu of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypotheses, null and alternative for mu are, they think that it's less than, so I would say the fourth one. The null is mu equals 1250, and the alternative is mu is less than 1250.
Ooh, I got a question for you guys. What kind of test is it?
So this is a
simple.
I can't remember.
We don't know the sigma.
Sigma's unknown.
Sigma's unknown, so it's
one sample mean with sigma unknown.
One sample.
Boy, I didn't know there were going to be extra tests on this.
I'm just kidding. It's just because I wanted to know. I need to know. Okay, in a statistical test of hypothesis, we say we reject the null hypothesis with a level of significance alpha. To reject it, it needs to be p-value is less than alpha. If it's low, reject the null. I could write a song about that.
I know.
Yeah,
I think of that, Juan. Whenever I'm like, okay, Juan said when it's low, reject the null. So I do that every time.
We can put it in collaboration board.
Yeah.
The song that you'll write.
Ooh, ANOVA again. It says a group of statistics students want to determine if a student in some apartment buildings get better grades than the students in other apartment buildings that wish. I'd move to that apartment.
Yeah.
They collect the GPA for an anonymous random sample size 15 for each of 4 different apartment buildings. The data for each apartment buildings are bell-shaped with no outliers, and the sample variance are nearly equal. Can we use the ANOVA hypothesis test to answer the question?
Yes.
Yes, because it's bell-shaped and there is no outliers.
And variances are nearly equal, so the third one.
Thus, you guys know. Wow.
So it says a medical researcher is working on a new treatment for a certain type of cancer. The average survival time after a diagnosis for the standard treatment is 2 years. So the null hypothesis is the average survival time after the diagnosis is the same for the new treatment and the standard treatment. So the null hypothesis is the average survival time after the diagnosis. So the null hypothesis is that they're the same for the new and the old.
Yes.
In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis, the null being that they were the same. In the future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The researcher has committed a type 2 error, right?
Type 1.
Dang it. I would have missed that.
Type 1 is when you reject it and you shouldn't have. But let me double check.
Right. She shouldn't have rejected it because it was such a small sample.
Yeah, that's for sure.
Oh, is it number 1? Yeah, you're right. How you don't remember that?
I looked it up yesterday. I remember it from yesterday because that question was on the review.
Yeah, I know. Even though there are many questions in the review.
I know. Well, no, I took notes on everything, but I do remember that because I had to research it. I had to go back. So when I have to research it, I remember it better.
Okay, so almost
14.
halfway.
14, if the level of significance alpha is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error?
It goes up. It
Yes.
decreases. No, I don't know.
Yeah. So the first one, by reducing the probability of committing a type 1 error, we increase the probability of committing a type 2 error.
Yeah, that's the one. That's the one. That's the one we want. Okay, so the nicotine content here is a certain brand and it's normal distributed. With a mean in milligrams, U and no standard deviation equal 0.17. The brand advertised that the mean nicotine content of its cigarettes 1.5, but the measurements on random samples of cigarettes of 100 cigarette brand is give the sample mean of 1.53. Is the evidence that the mean nicotine content is actually higher than the advertised? To answer the test hypothesis, so the null hypothesis, you equal 1.5 and you higher than 1.5. At 0.05 level of significance, you include that you should reject reject the hypothesis. There is a 5% chance that the null hypothesis is true. How to reject the null hypothesis or reject the null hypothesis? I think it's reject the null hypothesis, the fourth one.
If we so if we do the math and put it in the formula, which is sample mean minus the mean over the standard deviation divided by the square root of n, then
wait, how did you? What formula was that?
This is our very first. This is the z-score formula.
Oh, duh.
Because they give us all the information that we need for that.
I see. Okay, so the z-score
5, but the x bar, the sample mean is 1.53.
So you do 1.53 minus 1.5 divided by 0.17 divided by the square root of 100.
Yeah, 10.
So I get 1.76.
5.
Did I do that wrong?
No, that's right. 1.765.
Okay, and since we were trying to go against the 0.05 level of significance.
But that's not, so now we have to get the probability. Because we want to compare it to the level of significance. So you got to put it in the applet. And when you put it in the applet, and since it's greater than, I got the p-value of 0.388. And I want
Okay,
to double check.
I put 1.765, and then I highlight only the right side.
Right.
And I got 0.038.
Yes.
That is low.
So you reject.
So if it's low, reject the null.
Oh, that's right.
Bond's mantra.
Okay, so says you would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? So you would like to look at the mean number of hours worked for wages per week by male and female, which are independent, is an independent sample t-test.
Like that. So question 17 says, an educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling? In this case, definitely dependent sampling, because if you select a brother so as to compare his academic achievement to a sister, you must include the sister in your study. So the fourth one.
Because they're in the same home, is that why?
Yeah, they want to compare brothers and sisters. So if they choose this, if they randomly select this guy, they have to choose his sister.
Oh, I see. Okay.
Okay, a soil scientist collected random soil samples from field and measured dissolved organic carbons level of each sample. Measurement record in dissolved organic carbons. The researcher would like to conduct a 95% confidence interval for the mean dissolving organic carbon levels in the field. In our times of confidence interval listed below one of the appropriate situation. Okay, we have to do that thing.
That's a one sample t-test, right?
This is a, yeah, for sigma unknown. So the first one. So now, question 19 wants the confidence interval, margin of error.
Yeah, margin. And then we can do the same thing that we did before, put in the lower and the upper, and then
right.
Just do the
2.02.
Yeah.
Well, 2.025. So round to the third. You guys are gonna do so well in this exam.
I don't know. I don't think so. I need to study a lot, and I have another exam coming up, but it's a huge one. So I hate my life right now.
I know. I'm glad because last time I had a huge exam for econ the same week, and so that was challenging. But this week it's actually pretty normal, so I'm going to have a little bit more time to study.
This part is just numbers, so it's a good thing. So the lower bound will be 11.167, then upper 15 to 19. Margin of error will be 2.0 to 6, right?
I put 2.025.
But it's 55, so that means it's 6. You round it up, or you round it because it's in the middle.
I've got 2.025, but your confidence interval numbers were a little different than mine, Evelyn.
Okay.
Can you tell me what yours were again?
Well, the lower one was 11.67 and 15 to 0.219.
Yeah, see, I've got
11%.
I've got 11.168 and 15.217 for my confidence.
Oh, okay. Yeah, there you go. So that's why. Well, it's just because I calculated. I didn't want to do the Excel thing, but Okay,
okay.
just
I'm
doing
not
mathematics.
calculating, I'm doing the Excel. So I got 2.025.
It's kind of embarrassing, but I need to confess. Yeah, okay, so that
So
will make sense. Yeah.
2.025 is the margin of error. Is that right?
Okay,
Yes.
yeah.
And then the lower bound is 11.168. Is that what you guys have?
Yeah.
And the
Let
upper
me just
bound, 15.217.
Okay.
Is that what you have, Juan?
Yes.
Okay. So now we're going to look at Hummers. A random sample of Hummers for sale in LA and New York were taken from listings at cars.com. And so the data is in that Excel spreadsheet. We want to know if there is a difference in mean listing prices between Hummers for sale in LA, group 1, and Hummers for sale in New York, group 2. Create a 95% confidence interval for the true difference of mean listing prices between the two cities. So, question 22. Of the 4 types of confidence intervals listed below, which one is appropriate for this situation?
Okay. So, oh, I see. It's underneath. So we do the price for LA for. Oh, sorry. This is
Right. So 22. What confidence interval do we use?
So this. Whoa. Confidence interval for mu where sigma is unknown. Wait, confidence interval for the mean of difference. Using independent samples. Confidence interval. No, we don't do the difference of means, do we?
Yeah. Well,
these are independent samples.
Well, let's see. What is it trying to get us to do? It says
I think
the
mean and difference is
difference.
yeah, independent samples.
So it's trying to get us to
The third one.
We've got 2 samples and they're independent as opposed to dependent. So it's the third one.
I see. So that will be the paired sample T test.
So now it's asking for the.
It's a 2 sample.
Lower.
It's not paired.
Dang it.
Because they don't relate to each other.
But we want to find the difference, don't we?
Right,
Yeah,
but we find the difference in any of them. But it's just a matter of if sample A changes who we choose for sample B. And they're not related that way. Like a brother, sister, husband, wife, like that. Or one person doing 2 different tests, like a pre-test and a post-test. So they're not related to each other. It's Hummers in 2 cities, but the Hummer that you choose in LA does not determine the Hummer that you choose in New York to test the price.
I see.
Do you have the lower bound minus 423.158? I just very insecure right now.
Yeah, let me check real quick. Again, my computer's being slow. Minus 423. But that is
good. 423.
But that was the answer that they gave on the thing, and it wasn't the full answer. So hold on just a second.
I don't think that works for everyone, but it works for them so far.
Yeah, it does work for everyone.
Yes.
Oh, yeah, I got a negative number for my confidence interval.
Yes. Yeah, this one has a negative.
Both of them?
Okay, so I'm trying to wrap my head around this. So what kind of test would have been if we wanted to find the difference?
Well, we find the difference for all of them. Don't let that fool you, because anytime you have more than one, you're always finding the difference. It's just it's whether or not they're paired, or that they relate to each other, or dependent, or if they're independent, or if there's more than two. You're always finding the difference.
Okay, so here's an example, okay, just so I can explain it to someone and see if I can make sense of it myself. So if I took let's say that a student took a test one time, and he took a test another time, the same test, he retook it. Those two, wait. So
Yeah.
where would we use paired sample and two sample? Like, paired sample would mean if they... Oh, I know. So paired sample would be like if you're using a drug, right? Never mind. I can't make sense of it. I'll think of it.
No. So using your example, so if you've got one person and they're taking a pre-test and a post-test, so the variable A is them taking the pre-test. Does that decide who they're choosing for the post-test? Yes. Because they're trying to measure that same person for both.
Oh.
So that way A is related to B because they've got to be from the same person. Otherwise the test doesn't work. Because if they took Julie's test A and compared it to Joey's test B, then it doesn't make any sense. So the A and the B variable are related because they have to be the same person. And also, if they randomly choose this husband to measure something about him and they want to compare it to his wife, then that determines the B. So that's how they're related. So that's when you do paired samples. And it's important for paired samples because you've got to test A and B right next to each other. You can't mix up those numbers in that list. But with the other types of samples, it's just these numbers compared to these numbers all together.
Oh.
But you're always comparing the mean to, well, I guess if the paired samples, you're looking at the difference across. You're looking at the difference of the two scores or whatever it is. But when you're pairing, that's that. But if you're not pairing them, you're always looking at the difference, though.
Okay, so the New York and LA prices for Hummers, where the null hypothesis would be if they're the same, and the alternative would be if they are not the same. Right?
Right. But they're independent.
But if I was gonna study like the test scores for the same person to see if retaking a test is if it's better than the first time, then it would be dependent. Okay, I think I'm making sense to this.
Right.
Sorry, Evelyn. Am I losing everybody?
No, you're fine. That's interesting to understand because we will have an exam. And so it's very good that we're doing this.
Yeah.
I totally agree with this. It's fine. Don't worry.
Okay, so did we get for the lower bound negative 423.238?
Yes.
Yes.
For the upper bound 5,417.336?
Yes. What? Yeah. This time I got it right.
6. Okay, maybe reading the next question, I can like make more sense of it in my head.
Okay, go for it.
because this one is like, it's at the heart of what I'm trying to distinguish. Well, is everybody ready to move on?
Sure.
Yes.
Okay, it says many studies have suggested that there is a link between exercise and healthy bones. Exercise stresses the bones, and this causes them to get stronger. One study examined the effects of jumping on the bone density. One examined the effects of jumping on the bone density of growing rats. There were 3 groups. Rats were selected at random from the 3 groups: a control with no jumping, a low jump group, the jump height was 30 centimeters, and a high jump group, 60 centimeters. After 8 weeks of 10 jumps per day, 5 days per week, the bone density of the rats, expressed in milligrams per centimeter cubed, was measured. The rats are recorded in this Excel sheet. It says researchers would like to determine if the mean level of bone density are different between the 3 groups of rats listed above. Oh, that's just like an ANOVA test, right?
Yes.
Yeah, there you go. Mm-hmm.
Perfect.
Okay, so they don't want to know which one's higher, which one's lower. They just want to know if there's a difference.
Right.
And this Excel, let's see if I got it right this time. The test statistics will be 7.978.
Yes.
Okay, good. And the p-value 0.0. Oh, okay, 0.002.
Yes, that's what I got. And I have to say, I got that earlier today, not just now. I would not have had
All
to pop it in.
He doesn't like the answer of the test statistics.
Yeah.
Wait, 7.9 something, right?
78.978.
And then 0.001.
002. What I got.
0.002.
Yeah.
Which of the following best expresses the conclusion of this test? If it's low, reject the no. So we have sufficient evidence.
It's the third one, I think. Let's see.
Yep, at least one.
Mm-hmm. There is insufficient evidence to conduct that the mean bone density of all 3 groups is about the same.
Right. No, so not that one. The next one after that.
And then
There.
the next one after that.
Yeah, which actually is number 4.
All right, there you go. Oh, come on, no, another spreadsheet. Okay, so pressures of supplies and demands act directly on the prices for airline tickets. As the seats are available on the plane begin to fill, airlines raise the price and seats on the flight do not sell well. An airline may discount the tickets, even cancel the flight. The study was undertaken to determine if there is a difference in the mean cost of the airplane ticket purchased in 90 days in advance of scheduled flight compared with the tickets purchased only 40 days in advance. The data collect the cost of one ticket from London and Heathrow Airport variety destination in Europe, and then the lowest published ticket prices of one-way flight from the Heathrow, the various destinations in Europe, was recorded in each schedule 90 days in evidence that, again, 14 days in evidence the data are recorded. Perform the hypothesis test to determine the difference in the mean cost of non-stop flight when tickets are purchased with 14 days in advance and compared with 90 days in advance, and of level of significance for the next 4 questions. Do 14 days and 19 days analysis. What is the correct hypothesis test for this situation?
So what do you think, Juan?
Okay, so I've been like wrapping my head here. So they do have to do with the same airline, but they are different situations for the same airline. And the 90 days in advance doesn't necessarily affect the 14 days in advance.
Well, now, but this is where you've got to think about what she's actually testing.
Okay.
She wants to know if this ticket costs a different price 90 days or 14 days. So this ticket is for this airline, this destination, and everything. So with this ticket, she's going to look it up 90 days in advance. So in order to get the 14-day, she has to look up this ticket again for the 14 days.
Oh, so it's like the student with the test. It's
right.
Going to be dependent.
Right.
Because it's the same ticket.
Yes.
Just depending on the day.
Mm-hmm. Exactly.
Man, that's tricky. So where is like the key information? Because I feel like they all start out the same. I think the second paragraph might be like where I need to pay attention.
It really boils down to what the purpose of the test is. So for example, you could say, you know, we have these 2 drugs and we got 30 people to try this drug and we got 30 people to try this other drug. And then that would be independent samples. Or you could say, we got these 2 drugs and we got 1 person to try this drug and then later try this drug. And we measured that. In that case, they're paired because you're having the same person try both drugs. So it's really about what they're trying to find. And because you're always going to be taking the difference. You're either taking the difference of the samples or you're taking the difference of the means of the samples. So if the variable B is dependent on whoever they get for variable A or whatever they're testing for variable A, then they're paired. Did that make sense? Because there aren't specific words, there aren't specific keywords. Because there's always going to be a difference, so we can throw that word out. It's going to be more about if the A and B variable have something to do with each other or are determined by each other. Or if they're just completely 2 separate studies and they're just comparing the data.
Okay. Because it's like confusing because like that medicine that you were saying, it's kind of hard to see how that can be dependent when I guess I don't know. It would be more dependent if like the test subject or the patient was like taking the drug while he was running or taking the drug while he was sleeping. I don't know. In my mind, that is like dependence.
Yes, because the test subject is the same for both of the tests. So that's where it's dependent. So what I was trying to say was some of the words can be the same. I mean, you could take this question and you could turn it into independent sample test. But for this, because the ticket has to be the same for 90 days out and 14 days out, then it's related.
Okay.
And thus it's dependent on each other. But like for the medicine, if it's the same person and they're measuring them twice, then that's paired. Then they're dependent. But if it's two different people taking two different drugs, then it's independent. Or even taking the same
If you
drug.
want to make it dependent, if you want, you have to make a ticket, like one ticket to Brazil, to I don't know, Argentina. So that will be independent because they are different. There will be different tickets, so they will be independent in that case. But because it's the same ticket, you just want to know the difference, what happened with the same ticket, that will be dependent. If that makes sense? Probably I confuse you more, sorry.
So my confidence, what's that?
Go ahead. I was just going to say there is one trick. If they give you a spreadsheet and you look at it and like, did you open this one for the tickets?
Yeah.
So let's look at the spreadsheet real quick. It shows in column A that the airport, and then column B is the destination. Column C is 14 days, and column D is 90 days. So on row 2, we have 14 days and 90 days. They are both statistics based on the same ticket. So in this way, they're related. But when you have the unrelated ones, usually they're not spread like this. They usually go down a column. Remember for the ANOVA test, we had poultry and meat and beef, and they were broken out differently.
Oh my gosh, you're right.
So this tells you a lot about whether they're related to each other. Like on row 2, you have to keep those two numbers right next to each other because they have to do with the same ticket because they're related. They're dependent on each other.
Yes. So Adna Mandris Airport is the destination, and then I have the two prices for each one, and I'm trying to find out if there is a difference or not.
Correct. For that one ticket.
For that one ticket. Okay, my spreadsheet's probably broken. Some of my things are blank.
Yes, no, that's fine because she didn't have the data. And so what happens is when you put it into the paired test, it'll just ignore those lines. It won't count those.
Okay, so my test statistic for this guy was a 1.67.
Yeah.
1.6. I've got 1.685.
Let me see what I got lost there.
Yeah, I think I pasted these wrong.
Let me double check because I'm
1.685.
Yeah, I don't know what I did wrong, but get a p-value 0.009.
I've got 0.096.
That's what I meant. 0.096. Which of the following best expresses the conclusion of this test? Hey, we're almost done.
Yeah, we
Yeah.
are.
Okay, so since it's low, it's really low compared to the alpha. Wait, I was supposed to change it to a 99 or 90% confidence. Yeah, still the same. Okay, so if it's low, reject the no. So if it's low, that means there is sufficient evidence to conclude that there is a difference in mean cost of tickets purchased 14 days in advance compared to 90 days of advance.
Yeah, that's what I think.
Yeah. No confusion this time.
Yeah. Well, they did it correctly this time.
Yeah, I know.
Yay!
What?
Well, I'm gonna look over this YouTube video a lot because I need to understand what you guys are teaching me.
I wasn't teaching you anything. Well, so her. She's looks like I don't have that much time studying as well as her. So, well, she probably doesn't, but she does a good job with her time. Thank you so much for your help.
Hey guys, so did you miss 23 and 24?
No.
No.
I did. Did I type it in wrong? What did I do?
No, those were 0.5. If you go down to the very bottom, it should say 30 out of 30.
Oh, wait. No, I got number 24 wrong. I must have typed it in wrong. Oh, I did. I hit 3.7 instead of 1.7. What did you get for your answer for 24?
I got 5417.336.
Yeah, I typed 3.7 instead of 4.7 or 1.7. 5.41. See, I wrote it on my paper correctly and I didn't type it correctly. All right, I will fix that.
Have a great weekend.
Thank you. Good luck on the exam, guys.
Yep, good luck.
Yeah. Bye.
Thanks.
Yep.
Bye.